Our first presentation is Andrew Frazer from Passive House Australia. Andrew is a practising architect, certified passive house designer with the Passive House Institute in Germany, and a board member on the Australian Passive House Association. With 15 years' experience working in the fields of architecture and sustainable design, he is going to give us an introduction to the Passive House standard, its beginnings, and where it is today in Australia and around the world. The presentation will give an insight on the benefits and what it takes to achieve a passive house.
Okay. Thank you for coming. I'll introduce you to the Passive House standard if you don't know much about it. It's fairly new in Australia. There's 6 passive houses that have been certified to date. New Zealand is a little bit more ahead, and they're probably up to a couple dozen now. And the first one there was certified about 3 years ago now. Now, the Passive House aims to promote, raise awareness, support and network, and advance climate construction and regulation. Now, this will make a little bit more sense as I go through. The board is made up of 6 of us currently, and there's also a committee. So we meet, we Skype once a month. We had one the other night, and we're also always trying to promote and develop the Passive House standard in Australia. We believe it's very relevant to this climate where it's a lot easier to achieve than, say, in Europe, for example, so we'll go through that. So what I'll try and answer for you a little bit tonight is, what is a passive house, where does it come from, how is it achieved, how much does it cost, and what does it look like? So I might come back to this one in a minute, but this is a passive house just outside of Paris. It's got a second skin on it made of bamboo, and it's got retractable shading devices on it. Okay, so it's a voluntary energy standard for new and refurbished buildings. Now, the refurb criteria is less onerous than the new builds. Passive House have just introduced some different ratings within the standard now. It used to just to be Passive House and the refurbished component, which was called Benefit. Now, within new builds, they've actually got some classifications. There's Classic, Plus and Premium, and I can explain a little bit about that, but it's quite new. It's in a transitional phase. And they've also introduced a lower level standard again called Low Energy Buildings, which is PHI. Now, typically Passive House uses around about 80% less energy in its heating and cooling than conventional new buildings, and 90% less energy than existing stock. Now, it evolves to suit the climate, and what we use is what they call a PHPP, the Passive House Planning Package, to work through the design. It's not, the Passive House standard doesn't look at what materials you use. It's not concerned with embodied energy. It's purely a performance building and quality of the air inside the building. So health is a big component. So that's why it was developed. They're considered healthy homes, and they're considered highly efficient homes. Okay, so why target this? Construction takes up about 50% of the energy, in use is about 80%, and demolition about 5%. So that's why Passive House, we believe, is so important. A little bit of a diagram here for you. It's all about insulation. So again, it's fabric first, and to minimise the heating and cooling. It's not based on just throwing a heap of solar panels on the roof. It's actually looking at the integrity of the envelope and making sure it delivers. It's a very quantitative approach. Okay. So the Passive House Institute says the passive house is a building in which thermal comfort can be achieved solely by post-heating or post-cooling the fresh airflow required for good indoor air quality without the need of additional recirculation of air. And basically, would you pay full price for a fridge if its doors didn't seal? If your food, it'd keep your food cool, but the pump would be running all the time, costing you, loads of electricity. Why do Australians put up with leaky houses? So we have very leaky houses in this country, and the way we build is leaky, so it's very different to the European style. Okay, so there's the example. Oops, you've gone, yep. So there's your Australian house on the left, and there's a passive house on the right. Okay. So what's the passive house approach again? You've got the 19th century where you've just, traditional heating, and then we've gone to the 20th century with all our technologies. And 21st, we're saying with a passive house, well, we're keeping it simple, we're insulating well, and orientating the building well. Now, again, I'll go into a little bit more detail in a minute. So, the criteria. For heating or cooling, you've got to achieve 15 kilowatt hours per metre squared per annum, or a load of 10 watts per metre squared in heating or cooling. The primary energy demand is 120 kilowatts. Now, there's a factor that's taken into consideration, so that figure comes down from that, divided by about 2.6. But now what they've introduced now, they're phasing that out, and they're looking at renewable primary energy. And so there's a classic, a plus or a premium on what you're trying to achieve. Now, if you're getting up to the premium, you're doing very well at 30 kilowatts, and renewables at about 120. Air tightness, you need to achieve 0.6 air changes, no more than 0.6 air changes at 50 pascals. So it does require well-detailed buildings and well executed in construction. And the indoor temperature is typically around 20 degrees, 21, and it cannot exceed 25 degrees for more than 10% of the year. Okay. So in comparison, where does passive house sit? Approximately around the 8.5 to 9.5 NatHERS stars. Okay. Where does it come from? It started in Germany by Dr. Wolfgang Feist. So he's a physicist in 1988 and formally standardised in 1992. And today there's around 40,000 passive house buildings worldwide. And the commercial buildings are starting to take off now, so I'll show you some examples of those also. So that building in the bottom left-hand corner there was the first one that he did. It's a residential multi-storey building, or 3 storeys, and that was the first one to achieve the standard. Okay, so the Passive House Institute is an independent research institute. It has a freedom to develop the standard based on ongoing research, and it's based in Germany. There's also the International Passive House Association, which promotes the passive house, and if you actually go onto their website, you'll find a lot of useful information, and I'll give you some websites that you can go to. Okay, so there's a number of affiliates around the country, so you can see those there. So passive house is used around the world. And Australia is one of the more recent ones to join. So there you go. So that's where you'll find certified passive houses around the world. And this is where you'll find certified passive house designers or tradespersons. So in terms of becoming certified, you can either become a certified passive house designer or a tradesperson. So if you've got more of a qualification in engineering and architecture, like myself, you can get certified as a passive house designer. If you're more in construction, the builder, you can actually get certification in the trade and understand how to build the passive house. Okay, how's it achieved? Okay, so it basically looks at the losses and gains. Next slide. And it weighs those up in the planning house package. And so it looks at your internal gains, heat from ourselves, from equipment, lighting, so forth, your solar gains, and your heating gains, and it'll look at your losses, so through your windows, your walls, and your ventilation. Okay, so the thermal envelope. So it's all about basically creating an esky in a way. That's a simple explanation. So it's a well-insulated shell envelope, and it's very airtight. Okay, so there's basically 5 principles. So the first one, the bottom left, is insulation, so it's the level of insulation. It's passive house windows, so there are a lot of certified passive house components you can actually that have been certified by the Passive House Institute. so you can actually use those. You don't have to. The alternative, you actually have to go through the process of getting, if you don't have use their windows or the windows on their schedule, you'll have to get those windows certified through their requirements, which is basically through European standards. The ventilation system, which is a heat recovery ventilation system, I'll go into that a bit more later. It looks at, again, air tightness, and it looks at thermal bridging. So basically, to achieve the Passive House standard, you need to achieve a thermal bridge-free construction, or under 0.01 watts per metre squared. So, just how much insulation is needed? In Central Europe, an R value around 10, Ireland 6.6. In Melbourne, it's BCA requirements plus approximately 50%. So in Melbourne, that equates to around R4 for the walls, R6, and a concrete slab of R2, which requires some insulation under the slab. Okay, Passive House windows. So they provide some guidance on your region and what you should be targeting for your windows. And we basically sit in the warm temperate climate, so we're looking at the whole value, the U value of the window of around 1.3. So that's basically double low E glazing. And you might find in Tasmania you go to the cool temperate and you're going down to 0.85. Okay, so typically in Europe they're actually installing windows at about a U value of a 0.85 installed, which means the window is about 0.8. So they're extremely good windows. And just on the windows, before I learned about the Passive House standard, you'd think, right, I'll just put in some double glazing, but it's a lot more than that. It's the whole of U value installed. It's looking at the type of spacer, a warm spacer. It's the type of frame. It's the way the window seals inside the frame when you open and shut it, so it needs to be airtight. So again, you need to look into that carefully when you start specifying windows. And again, the Passive House standard recommends or has certified numerous window manufacturers. Okay, so ventilation system. So it basically uses a ventilation heat recovery system. It's very simple. They have to be at least 75% efficient. A lot of them are getting up over 90%. And their auxiliary electricity demand is very low at 0.545. Basically, it's, for those who don't know about how that works, it basically draws out the warm air, runs it past the cool air coming in from the outside without touching, and warms that up and provides you with the warm air inside, for example, in winter. If you design to the standard, generally you can get away with this alone. And that's all you need. There are 3 levels that you can use on this. One's bypass, where it doesn't heat up. So for example, in summer, you just want the fresh air coming in. They have a normal operation mode where it is bypassing, you're getting that efficiency, and then they have party mode, actually when you've got a lot more people in there and you need to freshen up the air inside your building. So I think one of the myths about, or one of the, people are reluctant with the Passive House maybe is the air tightness, and they're worried about it being stale and not being able to breathe, and why would you make a building airtight? Now, the principle is that, and the studies that I've done in New Zealand to date, are that Passive House buildings are a lot healthier inside than your average building, because they're circulating the air about 0.3 air changes an hour, but still low. You're getting that fresh air in, it's being filtered, as opposed to the stale air just sitting inside the house. So there's no requirement to keep windows and doors shut. So what you do is you may open doors and windows when it's a really nice day, but if it's hot or cold, you can close the building up, you make it airtight, you use the ventilation system, and you've got a healthy home without losing heating or cooling. So that's just basically describing how the ventilation system works inside the home. It can use what they call a Coanda Effect in the way it heats up the air. So it only trickles the air over. It's about 1.5 metres per second. So it's just gently recycling the air through the house and the whole house. So what you find in a passive house is that the air temperature is very constant in all parts of the room. The wall surfaces, the floor surfaces are all very constant. So even the windows, there can only be up to a 4K of a difference of 4 degrees in the surface of the inside of the glass to the inside temperature. So you don't get that drafting effect up the window, and you don't feel cold up against the window. So air tightness, basically they do a blower door test, and you do that at sort of end of first fix. The airtight layer is generally on the inside of the building. It's not the final layer, but you end up putting often they put a surfaces zone and then another layer of your final plasterboard, whatever you decide to line the building in. So you have a surfaces zone, which you can put all your power points, you can do changes, but you don't end up penetrating the airtight layer and losing that. So that's the principle. So again, a maximum of 0.6 air changes per hour at 50 pascals. And what we're seeing typically is on the next couple, I'll skip that slide, keep going, that one. They've just done a test of around 20 houses. The passive house standard is the purple line down the very bottom, that's how airtight that one is. And then you've got a well-sealed house, say today, sits at around 10 air changes, and your average sealed house is around 15. So, moving on. So, it's that uninterrupted airtight barrier. So you need to be able to draw it if you're going to be able to build it. And typically it sits on the inside, so you can see it's just indicated by the red line there. So generally it's internal. Okay, thermal bridge free. So you do a lot of modelling with the passive house standard, you do a lot of therm modelling, and you check for its thermal bridging and to detail it out of the building. So the devil is in the detail on passive house. It doesn't use a lot of technologies, but there's a lot of detail, and if you don't get the detail right, then it doesn't work. Okay. So it just says pick the house with insulation. So an outdoor temperature of -8, indoors 20, and the thermal imaging camera is not picking up the temperature on the one circled in red. It's down at -0.9, -2.3 with others. They're picking up the temperature at around 20 degrees, so it makes a big difference. Okay. So that's just a schematic about how the ventilation system works. So often the way they work is they blow the fresh air, or the fresh air comes into the bedrooms and living areas, and they suck it out of the kitchens and wet areas of stale air. And you can use a ground heat exchanger if need be. That can be tied into the system. There's a number of options on that if you need to. Okay. So the other factor is limiting your energy consumption. So the primary energy demand, you've got to keep that quite low to keep the standards. So again, things that everybody knows about is your equipment, light fittings, etc. And again, renewable energies is coming back into it. So the Passive House Plus and Premium takes into account renewables. Right. So, like I mentioned, there's the Passive House planning package. That's the package that you use, the program. It's a very complicated Excel spreadsheet. And to assist, I've actually developed a SketchUp to sit alongside with that called Design PH, where you can actually either design it in there or another program bring it in, and it ties in with the planning house package and imports the relevant information, windows, sizes, walls, areas, and so forth. Okay. So, for people interested, you can get certified as a passive house designer or a tradesperson, and you can, if you're in the fabrication industry, you can get your components certified. And if you do one of these buildings, you get one of these plaques down the bottom, and you stick that up on your house. So, okay, how much does it cost? There are additional costs in the windows and the whole house mechanical ventilation system, thicker insulation, but obviously there's cost savings. It's a simpler building generally. In the passive house standard, you look at the surface to volume area, and you try and keep that down as low as possible. The simpler the building, the less insulation you need. The more corners you have on a building, the more potential for heat loss. So I think they say for every 10% you increase in the surface area, you're adding another 20 mil of insulation. So if we could build a dome, that would probably be your most efficient, but it's not the most practical. So there you go. Right, but like it says here, there's intangible cost savings, health and well-being. So they feel like healthy buildings when you're inside them. They're incredibly fresh, and the temperature is consistent across the whole house. Okay. So, next, as a general rule, 3 to 8%. I guess it's becoming more tested, but we're saying 10 to 15% over and above. But again, it depends. I mean, the second house built in New Zealand was built by a young Dutch couple, and they built that one for around $1,500 a square metre. Now, that was a 2-storey simple box, and that's what they did. So I think it often comes down to the bells and whistles that you want on it also. Okay, so again, there's just some figures overseas on where the additional costs are. I won't go into that in too much detail. Right. Okay, what does it look like? Okay, so the characteristics are, like I mentioned, it is compact. Its area to volume, if you can keep it under 0.7, is very good. You don't have openings for chimneys and so forth. Your orientation, which everyone knows about, should be to the north here for your windows and so forth, and appropriate shading. And retractable shading is a big one. If you want to maximise your winter sun and cut out your summer sun, then the use of retractable shading is an important component. Okay, so this is a house. I think this one's in Canberra. Where's that one? Victoria. Okay, there you go. Yeah. So this was prefabricated SIP panels. Apparently this one was done. It's got an actually internal steel frame inside the SIP panel. So they must have had some very good thermal bridging between the skin and the framing to achieve the thermal bridge-free construction. But that was done by an individual, and there you go. So I'm going to have to move quite quickly. Next one. Right, this is in South Australia. This was the first one built in Australia, actually, out at Pages Flat. Okay, so originally, as I understand, it was by an architect. Was done by an architect. I've forgotten his name now. Max Pritchard, and then the client decided to turn it into a passive house, and there we go. The next one, Kingston in ACT. So a passive house can look like anything you want. So it can be very simple, or it can be more architectural. Keep going, and right, so some examples overseas. Apartment complex in Switzerland, and you can just flick through these. Apartment complex in Austria. Now, as I understand, all the social housing in Austria is actually done to the passive house standard now because of the low energy use. A community centre in Austria, and sort of keep going. School in Germany. right? Okay, archive building, exhibition building in China, yep. Okay, you might have seen this one on Grand Designs. Okay, so that one would have needed a bit more insulation than what if it was just a standard box, because it's got some interesting shapes and some thermal bridging issues to deal with. Okay, a house in New York. Now they're actually doing a high-rise multi-storey building in New York now to the Passive House standard. Okay, keep going. Commercial tower in Vienna. Now, quickly, you want to know more? There's an international Passive House conference every year over in Germany. And that's in 2017 in April. And what we do here is between New Zealand and Australia, we have one here and then one over in New Zealand. So the one was here early this year in Melbourne, and the next one's coming up in Christchurch. There's also Passive House Days. There's an International Passive House Day on the 11th and 13th of November, and which attracts over 900 buildings in 30 countries. And you can also stay in one. So if and again, I can give you these websites. You can have the experience to stay in one. There's nothing in Australia at the moment, but there's one in New Zealand that you can stay in. Okay. Skipping forward, I think I've been over this. You can, as part of joining the Passive House Association, you've decided to join, you get membership to the IPH with the International Passive House Association. Includes Passipedia, where there's a heap of information on passive houses. You get discounts on software. There's a regular newsletter and website listings. And the software is the PHPP9 and the design PH 1.1. You don't need that, but you'll need the PHPP. Next slide. So, can we do it in Australia? Yes. It's starting to happen. It's a favourable climate. We don't have the extremes. It's very much achievable. Next. Okay, and further information is there. I can give that to you later if you like. Is that the end? Okay, action, right. There are events and courses. There's a course coming up if you're interested in becoming a passive house designer or a tradesperson. They're coming up in November. And there you go. Right. Any questions?
We'll take the questions.
Yeah,
After
no worries.
the question.
Thank you.
Thank you.
Okay.